All right, Algebraites, on this lovely day, we are going to rewrite, evaluate, and graph log expressions and functions. The nice thing about the graph today is that we're going to be using a tool rather than just doing by hand. So, first off, how do we rewrite these puppies? The first one, this is my base, 5 to the third power, beep, 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 is 125. Now, generally speaking, you're going to end up with the true statement. 5 cubed is 125. Word to your grandmother. Now, let's take a gander at this other one. Please tell me what the answer is. So, after we look at all the rewriting here, let's look at something called the common base. Since we use 10 so much, we have 10 fingers, 10 is called the common base. Because we often say 10 to the 1, 10 to the 2, 10 to the 3. In a bunch of different contexts. Therefore, common log is this. It's log with the base 10, but it's so common that we don't even write it. We just say log. So like I said earlier, we're going to see it a lot and not see it at all because we don't write it. So on your calculators, you will often see just a button that says log. Now, the iOS calculator, I think, actually has log 10, or at least mine does, my pCalc. So that's because it doesn't, it's implied in most calculators, just log. Next, there is another number that shows up so much in nature, so much so, that we give it a number. It's called E, which is approximately 2.718281828. 8459045. So natural log, which you're like, of course logs are natural. Well, natural log looks like this. If I took E as my base, that shows up a lot. It turns out we just have a shortcut for writing it. Instead of log base E, we just say ln. And of course, ln makes perfect sense because it's the log natural. If you are French, you would say log natural. Or if you're dyslexic, you would say natural log backwards. Okay, so natural log and common log show up a heck of a lot. So we also want to spend a little bit of time using your calculator just to evaluate. So let's look at this right here. This one's not overly complicated. Just find the button that says ln. Some of your calculators might actually say not ln, but l log with an E. Like that. So plug that into your calculator and see what we get. 0.54, and what's the last one? And now when we plug this in, notice that we're rounding it to the nearest thousandths place, 3 decimal places. 1.060 or 1? When you plug that in, is going to give me negative 0.405. Now remember what the negative does. The negative says take E, then take the reciprocal of 2.7, and then raise it to the power of a decimal. So we're shrinking, shrinking, and shrinking. On the bottom here, where we are graphing, all we have to do is use Desmos or you're graphing your TI, and we're just going to plug in log base 3 of x into the y function. So after I plug this function into Desmos, now notice what we also have to do. Clearly, every single one of these, and as you can see here, every single one of these functions cross at this x-intercept. So I can't use that as a weight. So if I zoom in here to this one, notice at 3, I'm at 1 here. So this is 3, 1. So what you're going to use is the trace function on your app, and then you're just going to figure out which one has 3, 1 as an option. And so that means this one actually matches there. So continuing on, plugging those in to see which one is which, and trace it real quick too, just to, for example, this one here. Although there's only one of them that dips downward like this, there's only one that dips down like this. Clearly, not only does it dip down, but it's going to cross at this point. Positive 2, positive 2, negative 1. So everything is verifiable with the tracing function there. All right, and now we can match up all the other ones, and your assignment is to finish both sides of this worksheet.